We're going to go over some inverse functions and their derivatives, but before we actually go over the general derivatives of inverse functions, I'd like to talk about the specific derivatives of inverse trigonometric functions. So for example, one of our inverse trig functions is y equals inverse sine x. Now, I occasionally get people who are like, they're like, wow, I'm so smart. I remember that that's the same thing as cosecant, 1 over sine. It's actually not. So the first thing I want you to note is that this is not 1 over sine x. 1 over sine x would actually be written as sine of x to the negative 1. This one is, so the definition of this is that if y equals inverse sine x, that means that x is equal to sine of y. So it's the exact opposite of sine. It would be the one where if you were trying to simplify the sides, like solve an equation, you would multiply. You would take the inverse sine of both sides to get rid of a sine. And we also call this arcsine. So you're gonna see sine inverse written either as arcsine or inverse sine. A lot of times we use the arc notation because people get really confused about that negative 1 and they think it's the same as cosecant. So just make sure that you do not write this as 1 over sine. So here is the list of all of our derivatives of inverse trigonometric functions. They look pretty complicated, and they kind of are. They're the hardest ones to, in my opinion, they're the hardest ones to remember. You might find others later on that are harder for you. I'm going to tell you right now that these 3 are really important. You should probably just memorize these, or at least put them in your notes. The bottom 3 are less important because with the bottom 3, you can get it using the top 3 and the quotient rule. Not the most ideal thing to do, but if you're really not good at memorizing things, that's the way to do it. So these ones, however, are pretty important. They will come up. So unfortunately, you do need to know those top 3 ones. One little thing that might be helpful to notice is that the sine and the cosine are the same thing, except the cosine is negative. So you probably can get by with just memorizing 2 of them, memorize the tangent, and then memorize either the sine or the cosine, and then just remember the cosine is a negative. So let's do some examples. So here's my first example. I have y equals x times arctan of x. Keep in mind that arctan is the same as inverse tangent. So we had on the previous page that the derivative of inverse tangent was 1 over x squared plus 1. I do want to comment on something before I go on. I almost made a mistake on here. Don't forget, by the way, to make sure that, don't forget to put your x in there. If you just put inverse tan without an x, you actually will lose points. It's something silly to lose points on, but you can't take the inverse tan of nothing. You have to have a variable in there. So anyway, back to this problem. We have x times inverse tan or arctan of the square root of x. If it makes you feel more comfortable to rewrite the thing I just wrote as arctan, I'm certainly fine with that. But either way, just remember they're the same thing. You may notice that this is one where we have to use the product rule. I have x that's being multiplied by arctangent of x. Don't forget that if you have a product, you need to use the product rule. So to find my dy dx, I am going to use product rule. I'm going to start with my first thing, which is x, multiplied by the derivative of the second thing. So the derivative of arctan times the square root of x, you can remember that square root of x is the same as x to the 1/2. So I am going to do I have to use my chain rule in addition to the product rule. So I know, this is my second thing, this is what I'm taking the derivative of right now, arctan of radical x. I know that the derivative of the arctan is 1 over x squared plus 1, I actually need to take the derivative of arctan, but remember when you take that derivative, you're going to keep the inside the same. So my x is going to be replaced with a square root of x. So don't forget I'll show you what I did. I took this x right here and replaced it with the inside that I have for the square root of x. This one I think it's confusing for people because it's one of the first ones that they see that isn't just like a power, so it's a little bit harder to do this one. So then I'm going to multiply that by the derivative of my derivative of my inside. My inside in this case is square root of x, or x to the 1/2. Derivative of x to the 1/2 is 1/2 times x to the negative 1/2. There was a lot going on. Once you get all of this done, don't forget that you're still in the middle of the product rule. Don't forget to do the second half of it. Second half, luckily, is much easier. So then I do the derivative of the first thing times the second. So derivative of x is 1. So then I get plus arctan of radical x. Usually I would say don't simplify, but this one is not that bad to simplify. So we have an x on the top. In the bottom, we are going to have square root of x squared, which is the same as x plus 1. I also, from this yellow part right here, that's the same as 1 over 2 radical x. So I'm just going to write that out front, 2 radical x. And then my final thing is plus arctan of the square root of x. So, sorry, my answer is a little bit messy, but this is my final answer right here. You can simplify this a little bit more if you want with the x's. You don't have to, but if you were to simplify it all the way, your x to the first and your x to the 1/2 would, you would subtract your exponents, and this would actually be your final answer. The only time when I would really be concerned about that is if you were doing a multiple choice question. This would probably be how it appeared, so just make sure you're aware of that. So for my first one, I have y equals arc cosine of 1 over t. I wrote out the rule on the side for inverse cosine or arc cosine, so you can use that to help you out. This is actually going to be a dy dt. Be careful about variables. Don't write dy dx on this one. So we are going to use the chain rule on this one. Remember, with the chain rule, we're going to start with our outside thing. So my outside thing is the arc cosine. My inside thing is the 1 over t, which is the same as t to the negative 1. So when I take the derivative of the outside, I end up getting negative 1 over the square root of 1 minus, and now I'm going to do the inside squared. So I get minus 1 over t squared. Now I'm going to multiply by the derivative of the inside. Derivative of t to the negative 1 is negative t to this negative 2 power. There are ways to simplify it. You can simplify if you want to. I'm happy if you just write it as negative 1 over the square root of 1 minus 1 over t squared. And then actually this 1 becomes positive because I have a negative with my t squared. So, and then I'm just going to put my t squared out front. That's from the t to the negative 2, by the way.